In the last video, we refined a script for plotting an exponential decay curve versus time for a hypothetical chemistry experiment. I've got that script right here. I've called it exp decay refined. And if you remember, we added this call to the par function, and that let us set the MAI graphics parameter, which is the margins parameter. And we were able to reset the margin at the bottom, left, top, and right of the figure to leave the white space that we wanted for our graph. Also, we added these xlab and ylab arguments to the plot function that let us put specific labels, including the units, on our axes. So if I run this script, we now have a nice professional looking graph with not any extra white space on the top and the right as we had before. And also we have a full documentation of our axes where we have the variable that we're plotting, concentration versus time, as well as the units, milligrams per liter versus minutes. So I thought we'd use this as an example to see how we can put multiple plots on the same graph. For example, maybe you'd want to compare what a exponential decay with a 0.1 per minute decay rate would be versus a 0.2 per minute decay rate. And let's see, we want to put that on the same graph so we can compare the difference of those two things. So instead of 10% per minute, what if we're dropping the concentration by 20% per minute? Perhaps you can already imagine that that should be a steeper decay curve. So let's talk about how to do that. First of all, we're going to want to run this with two different settings and record two different sets of concentrations. So I'm going to go back to our original code here, and I'm going to add more to the variable name c and put c underscore 0.1, because this is the concentration curve relative to a Kr of 0.1. So we're going to do all of this the same way. We're going to generate a curve with the decay rate at 0.1, and then we want to change that decay rate to a different value. We're going to set it to 0.2. Then I'm going to copy and paste this code to say, well, in this case, I'm going to redo this calculation. Instead of Kr being set at 0.1, it's now set to 0.2. So I'm going to call this the concentration subject to 0.2. And I don't need to change this code because it's already Kr and I'm changing the Kr up here. So I don't have to change this at all other than what I'm calling the concentration. So after running this, I should have two different sets of concentrations, one representing a decay rate of 0.1 per minute and the other representing a decay rate of 0.2 per minute. So I'm going to call my Windows device again because I want this to pop up in a new window. I'm going to leave my margins alone because I don't really want to change anything about those margins. I'm just going to be adding an extra plot in the graph. But before I do any plotting, I'm going to do myself a favor and I'm going to define the formatting that I want for what I'm plotting. So in this case, I've got two different things that I'm going to change in terms of the formatting of the plots to make it so you can see the difference between the two plots. I'm going to change the color and I'm going to change the symbol used in the plot. So I want to define a value for the color associated with the C 0.1 plot. And I'm also going to want to define a PCH. PCH is the argument that you use for setting the character of the points. So PCH, point character. And again, I want to change that for C underscore 0.1. So one way there's lots of different ways to define colors, but some of them are defined by name. So in this case, I'm going to continue to make sure that my 0.1 is in black, which is the same as it was before. And the default symbol that it was using before is the symbol represented by 1, and that is a little circle. So when you there's a set of symbols that you can look up for PCH based on an integer value. So 1 corresponds to a circle, and we're going to use 2 in a minute that corresponds to a triangle. So if that's for C 0.1, I want to do the same thing for C 0.2. And a similar idea. I'm going to try to use a colorblind friendly palette here, and I'm going to call this dark orange. Again, you can look up what these numbers and what these strings mean. There's lots of different ways to specify colors. This is just a quick way. And there's actually several different ways to specify point characters too, but you can look up a table of what these integers stand for. So a 1 is going to be a circle and a 2 is going to be a triangle. So the reason I want to specify these as variables is because I need them in more than one place. The first place I need them is in this plot command. I need to add arguments that will let me change the color and the point use for this plot. In this case, I'm going to be plotting C underscore 0.1, which is the same curve as I was plotting before. But now remember, I renamed that variable, so I have to change my Y here. And I'm going to change the color I'm plotting to the color for C 0.1. And I'm going to change the PCH argument to be the PCH value for C 0.1. So that's these two values here. Now in base-R graphics, if you want to add a plot to the same axes, you call a different function. I can call points, and what points does is add a new set of points to the existing axes. It has similar arguments in terms of getting at the vector of x values. So in this case, it's going to be x equals t. Now y is equal to c underscore 0.2. Because I want to plot my second graph for corresponding to a decay rate of 0.2 per minute. I don't need to reestablish the axis labels because they're already here. Actually, you can't establish axis labels using points because this is for plotting on existing axes. But I do need to set the color and the point symbols to use. So I'm going to set this to call C 0.2. Don't forget the comma. PCH is going to be equal to PCH C 0.2. So the x argument is time, y argument is the concentration corresponding to a decay rate of 0.2 per minute, and then the color of the points and the symbol used for the points are going to be the color and the symbols that were defined for use with 0.0.2. Now, hopefully it'll become really clear why I'm using those variables, because if we have all of these things, we might want a legend. But let's go ahead and look at what this graph looks like first. If I don't have any bugs, we should now have a second set of points, and they're going to be triangles. And because the decay rate is higher at 0.2 per minute, you can see that we're dropping in concentration faster when you're using a higher first order rate constant. So hopefully that all makes sense in terms of the mathematics, but as I was just saying, we might want a legend here. We might want to say, what are the black circles and what are the orange triangles? We might want to show that directly on the graph. So let's talk about how to do that in base-R graphics. I'm going to call the legend argument, or I'm sorry, the legend function, which creates a legend on an existing graph. You can give x and y coordinates to put the legend anywhere that you want, but one feature is you can put in text for the x argument that specifies relative to that graphing area, where do you want the plot? In this case, if I run this again, we've got lots of space in the top right corner of this graph. So one of the ways to specify where the legend is on the figure is to just put in text here, top right. And that will specify it should go in the top right of the graph. You can do a help on legend. And you can see all of the different things you can use for x and y in order to set that. In order to determine where the graph is, or where the legend is going to go. So we only need an x argument if we're going to set it that way. The legend argument to legend, which is a little confusing, but this is what we want our text to be, to go in here. So in this case, I'm going to get a little bit fancy here, and I'm going to use expressions again. So I'm going to use a C to create a vector, but in this case, I'm going to create a vector of expressions. And the main reason I want an expression here is because I want an exponent again in my units. So in this case, I'm going to say K. And in this case, I want a subscript. Because in my mathematics, if you go back to the slides in that presentation, you'll see I have a K sub R, not just K sub R. So I want the R to be a subscript to the K to line up with my mathematical equations. To specify an equal sign in an expression, you actually put two equal signs in a row. And then in this case, our first element of our legend is going to correspond to a K of being 0.1 per minute. So I've got a 0.1. I want to create some space between my numbers and my units. So I'm going to use the tilde. And then I'm going to put minutes. And again, if I want an exponent, I put a caret. And because I'm going to put multiple characters, I'm going to use curly brackets. I'm going to put minutes to the -1. So this is a K rate constant of 0.1 per minute for the units. Then I just need to do the same thing for the second element of my legend, but in this case, the K is going to be 0.2 instead of 0.1. So that is the labels themselves in the legend. Then we have to tell the legend what points to put by those labels. So there's two things we need to change about those points. We need to change their color. So we're going to put color. And again, we put in a vector of values here because we have a vector of two expressions. Now we need a vector of two colors. And we've already defined what those are in variables, right? We have call C0.1 and call C0.2. And this is why I set these up as variables. So now if I go back in this code, I want to change this to be something other than black. I only have to change it here. I don't have to find all the places where black is defined through the code. Same idea with PCH. I need to give the point characters for the symbols that go on the legends. And again, I can use those variables that I've already defined with the PCH, appropriate PCH values corresponding to the two graphs or two plots that we're putting on this graph. So now, unless I've created a bug, if I run this, I should have the same graph. And now I should have a legend in the top right corner of the graph. And one aesthetic for me is I don't generally like to have a box around my legend. That's a personal preference. That's something that you can turn off with using the BTY argument. That's box type. And if you say BTY equals N and stands for no, that means don't put a box. So if I do this one more time, now my legend doesn't have a box around it. So that should give you a taste of what you can do with these base R graphics and how you can make nice professional looking graphs with legends, with multiple plots on them. And these are skills that you're probably going to need through the rest of this class. Also, hopefully I've just given you an example of all of the different arguments you have access to and how you might look up those arguments using the help function. Because ultimately you might find a lot of ways of tweaking these things on your own.